Today I'll be starting with the DP section of CS problem set. I'll solve the questions and explain them in a beginner friendly manner. So what is DP? DP is just a technique which is used to prevent calculating same values again and again, or simply when we want to use data from previously calculated values. It just helps us in reducing time complexities. I'll be starting with the first question, dice combinations. Now, in this question we are given our task is to count the number of ways to construct a sum n by throwing a dice one or more times. Each throw produces an outcome between 1 and 6. So we are given an example. If n is equal to 3, there are 4 ways, like 1 plus 1 plus 1, 1, 2, 2, 1 and 3. As we can see, we can have an ordered pair here also. We are just given an integer n, and we have to print the number of ways modulo this, and we are given constraint of n. So let's start. First we'll include this library. We took the integer as an input. We'll create a constant int for modulus, and we'll also create for the array. Let's create a long int dp array of size mx. We have created our array, dp array. Now, what this dp array will store? This dp array, dp of n, will represent the number of ways to get sum n. Now, so dp of 6 will depend on dp of 5, dp of 4, dp of 3, dp of 2, like that. So simply dp of a particular n will depend on dp of n minus 1 up to dp of n minus 6. Simple. So this is just basic. Like the number of ways to get sum 13 depends on sum 12 plus throwing a dice and getting sum 1, sum 11 plus throwing a dice getting sum 2. That's just basic. So simply we are going to iterate through this, all the values, and we are going to check for all the places from which we can reach here. J is less than equal to 6. But the problem is, like, if it is dp of 3, we can't go to like 6 previous places. Now it will be minus 3. So it will be minimum of I comma 6, j plus plus, and simply dp of I, which is equal to dp of I plus dp of I minus j. Simply we are going to see out dp of n, basic. But there is one problem here, like we are just calculating all the dp's values, but it is global, so it is going to be 0, so everything is going to be 0. We have to write a base case. What will be the base case? dp of 0 is equal to 1. As only way to get 0 is by not throwing a dice. Only way to get sum 0 is by not throwing the dice. So like, let's try to submit. Hopefully it will get submitted. And other things also. I wrote it like this. If I had written like dp of I plus equal to dp of I minus j hash mod, that will give error, because first we have to take mod, then store it in the dp value. It got accepted. And what else things? There are like many ways of solving. We can do recursion, tabulation, space optimization. I personally prefer tabulation, like it is like best of all three. Not only we are storing all those values, we can also backtrack to solve other questions also. So this is a basic question. As we keep on moving forward, so you'll get a better idea of how to solve this. Now moving on to question number second, minimizing coins. In this question, what we are given, consider a money system consisting of n coins. Each coin has a positive integer value. Our task is to produce sum of money x by using the available coins in such a way that the number of coins is minimum. So if we are given 157, our sum is 11, the optimal solution is 551, which requires 3 coins. So simply we will be given a number like what we want to get. First let's take an input. That's better. X same x, and we'll have vector line contains n distinct So simply we'll be given an array of coins, and using that coins we have to find the most optimal solution to get a desired sum 11. Simple. We are given constraints, so it's like the previous question. If it is not possible, we'll print -1. Simply like the previous question, let's create constant int mxn, which is equal to 187, y is equal to 189 plus, and long int dp of mxn. Like the previous question, it's the same here. dp of n will give the minimum number of coins to get sum n. Simple. Using the array which is given, the cost array. Right. So what? First I'll solve it. Then what we are going to do is, first we are going to minimize the dp using all the n coins which are available to us. Let's see. So what we are going to do, we are trying to minimize the dp using all the n coins available. We are trying to minimize dp using So simply we are first traversing through all the dp values for 1 to x, because that's the maximum sum we want. Then for each value we are checking using all the coins available given to us in the array Like if the size of the coin is less than equal to I, like if that particular coin value is 8 and the coin in the sum value we want is 8 and that particular coin value is 5, then we'll use that coin to check whether the value can be reduced or reduced like minimized, or we can reach a particular state like dp of 3. dp of 3 if we can do, so simply we'll go to that particular dp value and add +1 to it, as there will be like one more method, simply one more coin. We don't want to we don't want the number of coins, we don't want the values of coin, we just want the number of coins. So simply we'll be doing +1, and here I am like for each of the coins I am simply storing the dp value to be 199. I am used an integer here. We can use memset to like store it also, or we can create a vector like pre-initialized values, and simply you are going to check if dp of x is greater than or equal to 199. So we can't reach that state, -1, otherwise simply dp of x. So most probably it will work. Also one more thing I'll write important thing. First let's see if it is working, then I'll tell that thing. Also the video is getting recorded now. Okay, so it accepted. Now I'll tell. See how to think this. We can the outer loop is having coins because that's what we want to reduce. Simply. We can't reverse the order of x and n in loops because we are filling for base case first and then using that base case to fill other values. Simply first we are going to see if we can reach this sum 1 dp of 1 using all the coins, then we are going to go to the dp of 2 and then we are going to check, and we are going to do it like that. So this question is also done. It's a pretty easy question. Now let's go to question number 3. Coin combinations. In this question, it's like the previous question I suppose. We are given a money system consisting of m coins. Each coin has a positive integer value. Your task is to calculate the number of distinct ways you can produce a money sum x using the available coins. We are given some coins and desired sum is 9. There are 8 ways. Simple. It's actually like the previous question, but in the previous question we just have to put if it is possible or not possible. Here we have to find the number of ways. I think I'll still write the code from scratch. mxn which is equal to 1 is 7, mod which is equal to 1 in 9 plus 7, and a long dp of mx. This is done. There are no test cases in CSES, but the time constraints are like very high. So int n x we are going to take all the simply like the previous question, dp of 0 is equal to 1, not selecting anything. Now in the previous question what we did is this dice combination question. We are simply checking if the cost is less than I, we are going to minimize it using the values, but here we don't have to minimize, we have to calculate the number of ways. So instead of minimizing we are simply going to add it. So I'll is equal to 1, I is less than or equal to x, I plus plus See, indexing is here. It is indexing from 1 to x because it's the dp array. We are using from the base case to here. The zeroth we already calculated. We have to calculate from sum 1 to x. Here it's 0 from 0 to n because it's the array. It is 0 indexed. in case someone gets that doubt. Now simply, if the cost of that particular coin is less than equal to whatever sum we want to have, we are going to simply minimize the DP value minus the cost of that coin. And simply we are going to see out DP of x and basic. In the previous question we were just minimizing, here we are just adding the values, and we don't need to worry like if that state can't be reached, then it is obviously 0 already, because we have initialized the array globally, so all the values are going to be 0. Okay, this also right. Okay, so now the next question. In this, it's the same question. The difference is we have to calculate the number of distinct order ways you can produce some money sum using the available coins. Okay, so it's just the same as previous question. See why I'm writing the code instead of copying from the previous question. Like it's a very good habit. Not only it like increases your patience, but also it reduces the chance of error. Like the previous question, DP of 01, as we have, as it is not checked. Yes. The only difference in this question is we have to find the distinct order pairs. So if we do it in the same manner as the previous question, it will give us wrong answer. So instead we are going to swap these two loops. Why are we going to do that? I'll tell you after, like I submit the plus. Also here it is going to be C of I as the loops are reversed. Now the outer loop is for coins. Yes. In case someone get confused. See, I and J are swapped, so be careful in that. Here I'll be writing J. So why do we swap? Why did we swap the loop? See, let's go to the example of this question. First, if we can use the 2, we'll use it. After that, we are going to not use it again. So simply first we are going to get a particular coin. If we can use it to minimize that particular DP, we are going to use it. Otherwise, simply we are going to go to the next coin. That will help us in getting the ordered pairs. See, in this question, it was reverse. We are going through all the sum values and using the coin. So you understand now. So basically, to get the ordered pairs, we are doing this. Like these 4 questions are like basic, like related to one another. Now going on to the next question, removing digits. So, it's a different question now. So we are given an integer n, and on each step you may subtract one of the digits from the number. Okay, instead of like coins, we are just going to subtract the digits from that number. How many steps are required to make the number equal to 0? We are given an integer n, and we have to print the number of ways. We can actually do BF, we can also use graph theory to solve this question, but maybe due to constraints it will give some TLE or something like that. Yes. Constant in mx, which is equal to 1 is 7, and declared in dp of mx. dp of 0 is simply 0, not 1 here, because how many steps are required? Like if the number is 0, like there are no steps required to make it to 0. Now before I go further, see, if there is a number x, we want to get the remainder of it. We do x by 10. If we want to divide it by 10, we do this. Like for example, if number is 253, on doing mod we'll get 3, on dividing by 10 we'll get 25, not 25.3. It is like typecasted into, if it is integer, it's like a round of value. So what we are going to see, we are going to run another loop for j equal to I, j no constraint, j that will equal to 10, and dp of I is equal to minimum of dp of I comma dp of I minus j mod 10 plus 1. So dp of I. We have to minimize now. So instead of array, let's use a vector here. It's the same thing. As it can't be greater than n, so there's no need to like store like 1e6, 1e7, whatever. So first let's see if it is working. After that I'll explain you the code. I do hope it will work. Okay, so what we are doing is this dp array. This dp array is simply storing number of steps to make number 0, minimum number of steps. So dp of 0 is 0, simple. Then we are going to go through all from 1 to n values. N is the number we want, so we'll see out that. And then what we are going to do, if the number is, let us assume a, b, c, d, then we are going to take that number into another variable j, and j will be, it is currently abcd, right? We are going to minimize the dp of I using I minus, we'll subtract the last digit first, this one, d. I abcd minus d means abc 0. Similarly, then after, if we can minimize it, good. Then we are going to store the abc in it, in that particular number, and we are going to try to subtract the, to minimize the dp of I. I is always abcd, and then we are going to see if we can use c to subtract it. Then simply b and simply d. Simple question. So this is also done. Great. Now going on to the next question, grade. It is 24 minutes. We are given an n cross n grid whose squares may have traps. It is not allowed to move to a square with a trap. Your task is to calculate the number of paths from upper left square to the lower right square. We can move right out down. The first input line has an integer and the size of the grid. After this, there are n lines describing the grid. Each line has n character, this denoting it. So, This is like basic from what we have done in all the previous questions. Now to take for like my personal way is like to taking the input, like create a vector of strings. And I'm also initializing the size of vector because in the CSES problem set the constraints are like very tight. We are going to take each of the rows in the string. Now DP array, what this DP array are going to store is whether we can reach or not. Simply, we don't have to like Acha, we have to calculate the number of paths. So it's like the question in which you have to add. We don't have to minimize or just see out yes or no. Simply dp of 0 comma 0 is equal to 1. Simply if our lower and the upper or lower and the upper right square, lower top and upper right square are the same. Simply it's just one move. We start from here and we go there. Simple. Like we are starting at that position simply. Then simply we are going to iterate through the. As the constraints are very small, na 10 raised to 3, so simply we can use a double for loop. It's not actually a DP question, it's a graph question, but like due to the constraint, it can also be done using DP. Simply if that particular place is a star, we can't go there, simply DP is going to be 0. Else, if that I is greater than 0, we don't need to check for the I getting less than 0. I getting less than n, like we don't have to create another check function because it's a tabulation, it will not go further than n. dp of I comma j plus equal to dp of I minus 1 comma j. Similarly, if j dp of I dp of j and then we'll take the mod of these values. This question is, I think, self-explanatory. Simply we took the grid in the string and simply we are traversing through whole grid as the constraints are like 10 raised to 3, and we are changing the dp, first changing the dp values accordingly. Grid paths. These questions are like very simple, easy questions, so I don't have to think a lot about this. And s of I j is equal to star dp of I dp of j 0. Otherwise, we are simply going to add the previous, like last row and last column values to it and divide it by modulus. So this is submitted. Simply what we are doing is just like if we are at this position, well, at this position, we are going to check this and this values. If they exist, we simply add them. Otherwise, they are going to be 0 as the array is defined globally. And now let's go on to the next question. I'll probably solve 1-2 more questions, then I'll finish the video, as too many questions in a video like can be like very hectic for a person to understand. Oof. And also like very hectic for me to explain very in a good manner. Now going on to this question, next question, bookshop. We are in a bookshop which sells n different books. We know the price and the number of pages of each book. We have decided that the total price of the purchases will be at most X. What is the maximum number of pages you can buy? you can buy each book at most once. See, from this question, like how to think of DP, we have to find the maximum number of pages. So the DP won't be of pages. The value which will be stored in the DP will be of pages. So the DP value will be of this, well, price, whatever it is. First, let's take input. DP of a particular n will give us the maximum number of pages for a book with X money to spend for books with X amount to spend. So simply maximum number of pages we can get, right? What are the maximum number of pages you can buy? Maximum number of pages we can buy. Simple one-dimensional DP. This is like the basic of this question. So in this question we can see it's like the previous questions only. Like first we are going as what we'll do is we will try to use a particular book and see how many DP values we can reduce. Simple. For int I is equal to 0, I is less than n, I plus plus. For int j is equal to x, j is greater than equal to. See, the values which we are going to reduce is going to be here in this inner loop. But using a particular book, we can only reduce those values whose the amount of the book is greater than equal to that particular price. Simply HFI. See, if we want to see like DP of 3, DP of 30, but the book price is 40, we can reduce that DP, reduce this particular DP using that book, na? So DP of that particular gen is equal to maximum of, as you want to maximize the amount, DP of what? J minus, if you use a particular book, H of I, and after using that particular book, what we want the what is the maximum number of pages, na? So simply plus the S of I. Using that particular book, we are reducing the DP of J using this DP value, but adding this number of pages to the answer. Simple. And we are going to see out DP of X. Let's see if it is working. It's actually like okay, so it is working. Okay, this looks a bit lengthy. I'll skip this one for now. Maybe after the next question I'll catch up to it, or maybe in the next video. I'll just solve 1-2 more questions, then I'll like end the video. This question, counting towers. So, our task is to build a tower whose width is 2 and height is n. We have an unlimited supply of blocks whose width and height are integers. Blocks whose width and height are integers. Given n, how many different towers can you build? Mirrored and rotated towers are counted separately if they look different. We are given unlimited supply of blocks. See, using the diagrams, we can't create a block like this. So it is either like horizontal, diagonal, or mixture of both. Given n, how many different towers can you build? Mirror and rotated towers are counted separately. Okay, so like from array description, like good quality questions will be starting, I guess. I'll solve this question and maybe array description one also, and the rest I'll solve in the next video. See, there are even test cases given, so it's going to be a very good question. We'll just study two blocks, and with that we'll get the idea how to solve this question, as the width is only fixed to. So what are the possibilities? What's okay, so we have to comment both of them. I'll explain it very slowly, it looks a bit difficult question. So now what can happen is either these two can be connected, and forget about everything else like the height is n, just see, focus on this. These two can be connected, these two can be connected, these two can be connected, these two can be connected. Let's create two cases in which the dp of n, let us even forget about it. First I'll even show like the space optimization method. Yes, space optimization method. Let us assume these two are separate. As these two are separate, what are the possibilities that can happen? Either this one is connected, right? If these two are separate, this one can be connected, these two. While these two are connected, these two can be separate. So there are going to be two cases. When a top layer or bottom layer, you can say, is of separate. We don't care about anything else. When top layer are separate blocks, is of separate blocks. Let us call this 1, this is called 2, this is called 3, this is called 4. What can possible? 1 and 3 are connected, right? And there'll be two cases, like when 2 and 4 are connected and 2 or 4 are separate. So two cases here. And similarly, when 2, 4 are connected, there will be two more cases. And there will be one more case in which 3, 4 are connected. So one more case. So total 5 cases here. When top layer is joined, when it is joined, in that case, when it is joined now, what can happen is either 3 and 4 are separate, 3, 4 are separate, simply one case, or 3, 4 are connected, one case also, or 1, 2, 3, 4 all are connected, one more case. Total like 3 cases, so total 8 cases. Or I just explained to you like how dp of 2 will be equal to 8. I'll also solve this question in a mathematical manner later on. First I'll solve using space optimization, then normal tabulation, then I'll solve it in a mathematical manner. So simply what we are going to do is First, I'll see if it is working, then I'll explain the space optimization approach. X equal to 1, y equal to 1, and n, c in n. For int I equal to 1, I is less than n, I plus plus, int x2 is equal to 4 star x plus y, good, much more. Int y2 is equal to x plus 2 star y. Yeah, it should work, why is it not working? Okay, fuck it. I was thinking of getting all the green submission on the first two, but like, okay, there is still one wrong answer. I think it is just going to be this. If it still persists, I'll pause the video and okay, like, come on. Wow. 3 wrong answers, like, fuck me. So, even if you don't understand, like, there's no need to worry, it's a bit complicated. I'll first rewrite it. Like, that's even better. Like, x2 means x2. What does x2 means? When having a top block. When having two top blocks, right? And x means there are two blocks on previous top. So they can be connected in 4 ways, as I explained here, 2 and 2. x2 means when a top block, when there are two top blocks, and they can be connected in 4 ways also. Similarly, y2 means having a single top block. Means that cannot be split. No matter what. And similarly, y means there is a single block on previous top, which also cannot be split. And they can be connected in 2 ways. Simple. So like basically you can correlate this with these 4 cases. Simply x is equal to 1 and y is equal to 1. They're like 2 cases when there is a single block and there are double block. We'll iterate through the array. We are simply going to check, like we are putting a block. We are going to simply check 4 star x minus y, and this is for the 0th case, like 0, like 1, it will go from 1 to n minus 1, and this is for the base cases when they are single or double block, single block. And x2 is equal to 4 star x plus y, simply as they are going to be 5 ways for it, and this it is simply going to be for x plus 2 star y. And with each we are going to replace the previous values. For example, there is third, this is second, and this is first. Simply we have x value here, y value here. We calculated x2 and we calculated y2. We don't need the previous values now before x and y. So what we are going to do, we are going to replace x2 and y2 by x comma y, and then we are going to calculate this x2 y2. Simple. And in this question, this is the zeroth one. Like I'll write it so there is no confusion. Zeroth, first, second. And with this, we keep on going until we reach the n minus 1th. Simple. So now this is just to show the space optimization method. Now I'll solve it like in a normal manner using the DP method. Let's remove this and then CNN. Now DP, so we remove the solve function, constant in mode, we created. Okay, then we have to create a MX also. One is 6 plus 1. Why is it showing error? So now let's create a long dp of mx plus 2. We only created two, like connected and non-connected. The dp array, the dp array will be created. This is just space optimization. It's the same. The concept is same, but we are solving it using dp. What dp of a particular I, comma 0 will denote number of ways to add such that last two blocks are connected. And similarly, dp of I, comma 1 will denote number of ways to add such that last two blocks are not connected. I'll simply write the code. It's the same as the previous one, so I'll just speed up a bit. What we'll do is, instead of, we'll pre-calculate all the values. It's better to pre-calculating, as it will be the same for all the cases, right? Because the question is a standard now. Here it is fixed that width is 2 and height is n, so we'll calculate for as maximum number of values we can and just simply print the answer. dp of 1, 0 is equal to 1. dp of 1, 1 is also equal to 1. Simplify it is equal to 1 is left max. I plus plus. dp of I plus 1, 0. See, number of ways such that the last two blocks are connected. If the last two, not the last two, those two blocks are connected. Sorry. Two blocks are connected, two blocks are not connected. dp of I plus 1, 0 is, it will be dp of I of 1. Not connected case, see, x2 is equal to 4x plus y plus 4 star when they are connected, plus the case when they are connected, 4 star dp of I. Sorry, this one is for this case. Okay, I'll write it again. First, we are doing dp of I plus 1, 0 when they are connected. When they are connected, it will be this case, x plus 2 star. dp of I 1 plus 2 star dp of I, 0. And dp of I plus 1, in this case, plus equal to dp of I, 0 plus 4 star dp of I, 0. when the two blocks are connected, right? What can happen is either the below blocks are separate, only one case, or if the two blocks are connected, then they are like separately connected or they are forming a single block, this one case. Similarly, for the case when the two blocks are not connected, four cases when the previous ones are also not connected, plus one more case when those two are connected. When we took n, simply we are going to see out print answer. Answer which is equal to what? dp of n and 0 dp of n 1 hash mode see out answer. Let's see if it works. I will submit this. So here dp is like such those two blocks are connected. We are starting from 1 and we are going up till n, right? Here it was starting from the base case, so that's why we are going till less than n. So it got accepted. So this is the space optimization method. This is the tabulation method. I personally do tabulation. For it's better. Space optimization looks cool, but it is actually very complicated. And there is like one more method to solve this question. Because it's a mathematical question. It's like a Fibonacci question. Let's call it void maths. And maths will be something like that. Pre-2. Yes. What we do, instead of using a 2D DP array, we can simply create a 1D DP array. I'll not solve using this, I'll just give you the idea because already a lot of time has passed. So int, we'll create a DP of mx plus 1, DP of 1 is equal to 2, DP of 2 is equal to 8, and simply for int I is equal to 3, I is less than equal to n, I plus plus, dp of I is equal to 6 times dp of I minus 1 minus 7 times dp of I minus 2. And then we are going to simply see out dp of n. And 7. It's like a mathematical approach, I suppose. Like, let's comment this somehow. Oh, it will be pre2 now. We'll just call the pre2 function. We'll just simply you get the idea, na? Like, what do we have to do? It's the same thing. It will get accepted, so no problem. Simply, we are just going to store all the pre2 will be here instead of that particular value. Simply, we are going to mathematically store all these values, and that's it. Intensive, basic. It's like the best approach. Like if you can actually visualize the recurrence and find that there's no need for DP, there's no need for optimization, 2D, anything. So okay, mostly I'm tired. My fingers are hurting. I'll just do one last question. So we are given an array which has n integers 1 to m. Absolute difference has two adjacent values at most 1, where some values may be unknown. Our task is to calculate the number of arrays to match the description. We are given n. So I'll just solve the question first as quickly as I can. Then after that I'll explain it. Okay? See, okay, the video is playing. I thought I paused the video, right? So like while solving that question, I was just like listening to music. I thought I paused the video. Lol. So just one mistake here I see. So probably this is going to be the last question. I just wrote it like as fast as I could. So what we are given in this question is, what we are given is there will be size 3 5 and it will be 2 0 2. What we can do is we can replace this 0 with either 2 plus 1 2 or 2 minus 1. So there will be like 3 cases, 1 2 3, so the answer will be 3. So that's a very simple question. We can actually solve this question using BFS also. The video is playing now. We can actually solve this question using BFS also, but it will give TLA because of the constraints, as we have to take mod 10 raised by 9 plus 7. So simply, what do we want to do? I created a 2D DP array. 2D DP array. DP of I, comma j. What this will denote? Number of arrays of size I such that the last element is j. Number of arrays of size I such that the last element is j. Simple. This is what we created. So according to this, what will be our answer? Summation of dp of what's the size of the array we want, n, and what's the last element. Last element could be anything, we don't know. 1 up to k. K is the upper bound which is given to us. This is the answer. According to this DP or our answer will be this. See, we can create different type of DPs. We just have to like find the perfect relationship for it and like get the right answer. Like write this. So the last element is j. Now dp of I comma j. It will depend on what? The size I will depend on the size I minus 1, right? dp of I minus 1, it will depend. It will be equal to the last. Let us assume the jth element is 2. So the last element, which could be 2 minus 1, right? Plus dp of I minus 1 j plus dp of I minus j plus 1. So that, let us assume we have a particular size I minus 1 and the last element is something. No, we want a size I, the last element this. Then the which can only be constructed from an array, from a size of I minus 1, where these three are the last elements. Simple. This is the basic DP relation we can find. And now, what about the base case? The base case is when we have size 1. Size 1, if it is x, then it will be 1 only if the value is like a of 1, if that value is either 0 or x. Simple. Otherwise it will be 0. The size dp of 1, dp of array of size 1 such that the last element is x. So the element should either be 0 or x itself. If it is 0, we can convert it into x. Otherwise, all the cases it will be 0. This base case I have done here. I'll show. I'll first explain. See, REP is just like has defined, like when I'm like solving the question, I prefer to keep the code short as possible. So this is like for int I equal to I less than equal to b I plus plus. We are creating a vector of n plus 1. Here it is 1 based index. 1 based index. First we are going to take all the input in this array. Now we will create a vector of 2D. See, in the all previous question I created int, so here I created a vector, so that vector can also be used, like it's not a big deal. N plus 1, n plus 1, 0. Then for all the base cases, what we are doing, for int I 1 to m, we are simply checking for all the values. If that particular value is either 0 or I, we are going to replace that dp with 1. So simply we are iterating through all the numbers and we are going to see if that number is either 0 or I, to that particular base case is going to be this. Then simply we are going for both loops. We are going from 2 because first one we already calculated, and then we are going for j for 1 to less than equal to m. Simply the same condition. If that particular value is either 0 or j, if it is j, then dp of j will simply add the values, because we want to know number of ways to find the error that match the description. We are simply storing the values and going up to the last value. simply if it is 0 it can be changed. If it is j, there is no need to change it, but it will still store the dp values. So it can keep on passing till we reach the size n, and for different values, and then simply we are going to check for another loop 1 to m. Answer is equal to answer plus dp of nk hash mod. Simple. So I'll say like like 8th and 9th question. Matlab, 9th question was also like pretty good. Matlab, this 8th one is pretty nice. So if you have like any problem, it is thinking complicated, like replace the rep with for and try to submit and try to think again of this question. I'll explain it once more before like quitting the video. What the DP is doing is, we are seeing that if the particular number, we want to have a DP of size 3, and that element, last element should be 2. We are checking that how many ways are possible. Na? We are checking how many two size array are already possible. We have already calculated it. Whose last value is either going to be 2, whose last value is either going to be 3, plus whose value is either going to be 4. Simple. And also dp of 3 comma 3, also dp of 3 comma 0. This much we are only just doing in this question. So like I'm also tired. I actually wanted to solve as many questions I can do in like 1 hour, and it is already exceeded it. My fingers are hurting now, like too much. So I solved like 1, 2, 3, 4, 5, 6, 7, 8, 9. And after that the questions are going to be good quality ones. I'll keep them in a separate video, the part 2 video. And like it will get you like basic idea how to do DP. If you didn't understand, you can see the video again. I have like explained in as easier manner I could. So thank you so much. And also I'll not share any code now. The best thing is to write the code yourself, because if I share the code, some people will go just like submit the code and get the green tick. Like that is totally useless. Neither you are learning anything nor you are writing the code yourself. So with that, this part 1 is completed. Thank you so much for giving your time. Okay. Thank you.